start with organic chemistry. Let's start with classification of functional groups. So let's see the classification of organic compounds or functional groups. Now, the first list of organic compounds includes hydrocarbons. Then we have halogenoalkanes. And then we have compounds containing oxygen and nitrogen. Now, what do you mean by hydrocarbons? Hydrocarbons means compounds containing hydrogen and carbon only. So compounds containing carbon and hydrogen only. We call those what? Hydrocarbons. Let's see examples. The first up is alkanes. Now, what are alkanes? Alkanes are called saturated hydrocarbons. Why do we call them saturated hydrocarbons? Because you have carbon-carbon single bonds, and each carbon is making 4 bonds. So each carbon is making 4 single bonds, is why we call them what? Saturated hydrocarbons. They're unreactive. Why are they unreactive? Because they are saturated in nature. So alkanes have very few reactions, which we will see, but they're generally considered what? Unreactive. They follow a general formula that is CnH2n plus 2, right? For example, we have, okay, first I'll enlist them, then I'll give you examples of each actually. So these are alkanes. They're saturated carbon-carbon single bonds, unreactive with the general formula CnH2n plus 2. Then we have alkenes. Alkenes are unsaturated hydrocarbons. So these are unsaturated because you have a carbon-carbon double bond. And in the double bond, you know one is sigma and one is pi. Pi bond is weak, so it can break easily, leaving one extra bond on each carbon. Not one extra, but one vacant bond on each carbon. For example, if you have this alkene, right here we know one is sigma and one is pi. Let's suppose this one is pi, so the pi bond breaks. Do you see you have a vacant bond here and here? Yes? So you have vacant bond on each carbon, and that's why these are reactive. Also called what? Unsaturated hydrocarbons. So these are reactive than alkanes. And the general formula for alkenes is CnH2n. So that's the general formula. Then let's see alkyl functional group. What is an alkyl? It has one hydrogen less than an alkane. So it is one hydrogen less than an alkane. We call them alkyl. The general formula will therefore be CnH2n plus 1 because it has one hydrogen less. So rather than plus 2, it will be plus 1. Then we have cycloalkanes. What are cycloalkanes? These are cyclic alkanes with a general formula of CnH2n. And we will see each of these categories differently, each of these functional groups separately. We will differentiate between them. Then we have cycloalkenes. These are what? Cyclic alkenes, right? And the general formula is CnH2n minus 2. And then we have alkynes. Alkynes are where you have a carbon-carbon triple bond. The general formula for alkynes is CnH2n minus 2. Now, these are the hydrocarbons: alkanes, alkenes, alkyl, cycloalkenes, and alkynes. Now, let's see what are alkanes. So, alkanes are where you have carbon carbon single bond. Now, before we see what alkanes are, just know that if you have a carbon, one carbon compound, the name starts with meth. A two carbon compound, the name starts with eth. A three carbon compound is prop. Four carbon is bute. Five carbons is pent. Six carbons is hex. Seven carbons is hept. Eight is oct. Nine is non. 10 is dec. Now, you really don't need to know 9 and 10. You need to know naming up till 8 carbons. All right. So you need to know up till 8 carbon atoms. Anyway, let's see what an alkane is. They are saturated hydrocarbons, right? Means you have carbon carbon single bond. And the general formula is CnH2n plus 2, where N represents the number of carbon atoms. The simplest alkane is a one carbon alkane. So the simplest alkane is one carbon alkane where you will have all four single bonds around it. And this would be the simplest alkane. It's a one carbon alkane. Therefore, we will call it what? Meth, because it's one carbon, and ane because it's an alkane. So this is methane. Then we have a two carbon alkane. So two carbon bonds will be single. So 1, 2, 3, 4, 5, and 6 hydrogens around it. So this is C2H6, and this will be called what? Ethane. Yeah. Let's see three carbons. A three carbon alkane. So this would be 1, 2, 3, 4, 5, 6, 7, and 8. So this is C3H8, and this is what? Propane. Then you have C4. So you have 1, 2, 3, 4, 5. Do you see all carbon-carbon bonds are single? Yes. And this right here would be C4H10, that is butane. Now, do you see all of these? They follow the general formula CnH2n plus 2, where n is the number of carbon atoms. If n is 1, H 2 times 1 plus 2, C1H4. Do you see the general formula is being followed here? Where n is the number of carbon atoms. If you have two carbon atoms, H 2 times 2 plus 2. So this becomes C2H6. And that's exactly what we see here. If n is 3, it will be C3H8. If n is 4, it will be C4H10. Clear? Now let's see what alkenes are. Alkenes are unsaturated hydrocarbons. And why are they unsaturated? Because they have a carbon-carbon double bond. The general formula is CnH2n. Let's see the simplest alkene. The simplest alkene is a two carbon alkene because you need a carbon-carbon double bond. So the simplest alkene would have two carbons. You cannot have a one carbon alkene because you need a carbon-carbon double bond. So you will have one hydrogen here, a hydrogen here, a hydrogen here, and a hydrogen here. That's the simplest alkene. Yeah. You see, each carbon is making one, two, three, four bonds. This carbon also making one, two, three, and four bonds. Clear? Now let's name this. So this is C2H4. This is the simplest alkene and will be called what? A two carbon alkene is called eth. And because it's an alkene, we will call it what? Ethene. Clear? Likewise, let's see a three carbon alkene. So you have two bonds here already. This is the third, the fourth. This one has three bonds. Do you see one, two, and three? So you only have one bond left, that's the fourth. This has one bond, so it's two, three, four. This is C3H6. And this is what? Propene. Why? Because three carbons is called prop. And this is what? Propene. Clear? Let's see a four carbon alkene. A four carbon alkene. Let's see this. This already has two bonds. This will be the third and the fourth. This has three bonds. This will be the fourth. This has two bonds, third and the fourth. One bond, two, three, and four. So this is C4H8, and this is butene. Now, if you see here, the general formula is CnH2n. Yes, so you have CnH2n. If n is 2, H will be 2 times 2, and that's what you get here, C2H4. You see the general formula applies to all alkenes. C3H2 times 3, C3H6. C4H2 times 4, C4H8. Clear? So this right here is the alkene functional group. Let's now see alkyl. What are alkyls? They have one hydrogen less than alkane. And the general formula is CnH2n plus 1. So let's see. We often call alkyls as R groups. What do we call them? R groups. Now, let's see an alkane. You have a CH4, that's the simplest alkane, methane. Yeah, so you have, I'm just writing the formula, CH4. This is methane. One hydrogen less would mean CH3. So that would be this. This bond is vacant. You can attach anything here. Yeah, because this is vacant. It's not being used. So it's a vacant bond. Now, what will we call this? It is an alkyl or one carbon. So we will call this the methyl group. What will we call this? The methyl group. Because it comes from methane, but it's an alkyl. Therefore, it will be methyl. Let's see the next one. You have C2H6. So that becomes C2H5. And this is what C2H5 is. This is a vacant bond right here. Yes. So this right here is called an R group. And this will be called what? The ethyl group. Clear? Then you have C3H8. So C3H7, that would be the propyl group. And you will have one vacant bond. So you will have all of this. And you have one vacant bond here. Clear? So this right here is the propyl group. One carbon is methyl, two carbon is ethyl, four will be butyl, so on and so forth. And we can collectively call these what? R groups. Because on these, we can attach anything because they have one vacant bond. So far, so good. Any questions? All right, let's see the general formula. So this is CH3, N is 1, 2 times 1 plus 1. Do you see that becomes CH3? So the general formula applies to all alkyls as well. Now, let's move on to the next functional group. We have cycloalkane. Now, what are cycloalkanes? These are cyclic or ringed alkanes. So cyclic or ringed alkanes, right? Now, these, whenever you go from a straight chain to a ringed compound, whenever you go from a straight chain to a ringed structure, you always lose two hydrogens. So you always lose two hydrogen atoms from a straight chain to a ringed or a cyclic compound. Now, for a cyclic compound, you need a minimum of 3 carbons. So a minimum of 3 carbons are required for a cyclic compound. So you need a minimum of 3 carbons. So for example, 1 carbon can't give you a cyclic compound. Neither can 2. You need a minimum of 3 carbons to make a cyclic compound because 2 will give you a straight line. Imagine this is 1 carbon, the second carbon. It will not give you a ring structure. A ring is only possible with at least 3. Yes? Now the general formula for cycloalkanes is CnH2n. Yes? Now let's see. So we have propane, which is 3 carbon straight chain alkane. Yeah? I'm not putting the hydrogen, but you get the point that this is C3H8 straight chain propane. Yes? Now you can make a cyclic compound, and that cyclic compound would be right here, where each corner represents a carbon atom. Now, this right here is your cyclic compound, 1, 2, and 3 carbon atoms. Now, if you see, this has 1 bond, 2 bond. So the third and fourth would be a hydrogen. 1 bond, 2 bond. Third and fourth would be a hydrogen. 1 bond, 2 bond. Third and fourth would be a hydrogen. Yes? Do you see this has become C3H6? Do you see when you go from a straight chain to a cyclic compound, you have lost 2 hydrogens? Yeah? And what will we call this? We will call this cyclopropane because this is a cyclic propane or a cyclic alkane. Let's see. Butane. So you have butane. This is C4H10. Now let's see a cyclic butane. So you will have 4 corners, each corner representing what? Carbon. Now you have 4 carbons. Let's count the hydrogens. So this carbon is making 2 bonds. So third and fourth would be hydrogen. This is making 2 bonds. Third and fourth would be hydrogen. This is also making 2 bonds. Third and fourth would be hydrogen. third and fourth would be hydrogen. So this is C4H8. And this is what? Cyclobutane. Clear? So this right here is cyclobutane. Do you see from C4H10 you make C4H8? Again, from straight chain to ring, you lose two hydrogens. Clear? And if you see the general formula is CnH2n. So if you have three carbons, H will be 2 times 3 and that's C3H6. Clear? So this follows the general formula. 4 carbons, H 2 times 4. So this becomes C4H8. So the general formula is followed here. Clear? Now let's see cycloalkenes. Is this clear? So far, now let's move on to cycloalkenes. These will be cyclic alkenes, right? So they are cyclic alkenes. The general formula is CnH2n minus 2. And these right here also require a minimum of 3 carbons. Yes? So let's see. You have a 3 carbon alkene. This is propene. C3H6. Yeah? This is propene. Now you have a minimum of 3 carbons, which will make a cyclic alkene. Yes? Now between any of the 2 carbons, you can take them to be what? Double bond. Either this or this or this, doesn't matter. Any of the 2 carbons between them, you can show double bonds. Now, you see this carbon right here? This carbon is making 1, 2, 3 bonds. Fourth will be a hydrogen. This one's making 1 and 2 bond. Third and fourth will be a hydrogen. This one's making 1, 2, and 3 bond. Fourth will be a hydrogen. Yes? And this becomes what? C3H4. And this will be called what? Cyclopropene. Do you see from straight chain to cyclic, you lose 2 hydrogens? Yeah? Now let's see cyclobutene. So this is C4H8 butene. So you have cyclobutene. You can show the double bond here. You can show it here, here, or here. That's fine. So this right here, let's say, is a carbon-carbon double bond. This is already making 3 bonds. This will be the fourth. This is making 3 bonds. This will be the fourth. This is making 2 bonds, the third and the fourth. This is making 2 bonds, third and the fourth. And this becomes C4H8. That becomes C4H6. And we call this what? Cyclobutene. Do you see from straight chain, we make a cyclic compound by losing 2 hydrogens. Clear? And if you see the general formula, that applies here as well. CnH2n minus 2. So C3H2 times 3 minus 2. And that gives you C3H4. Clear? So the general formula also applies. Now let's move on to alkynes. What are alkynes? Alkynes have carbon-carbon triple bond. Yes? And the general formula is CnH2n minus 2. Yeah? So again, you will need a minimum of 2 carbons, or the simplest alkyne would have 2 carbons. Yes. So you have a carbon-carbon triple bond. Each carbon is making three bonds. This will be the fourth. This will be the fourth. Yes. So C2H2. This will be called what? Ethine. Clear? Because it's of two carbons, made of two carbons, alkyne. So this will be called ethine. Understood? Let's see a three carbon alkyne. This has one bond. So this is the second, third, fourth. This is already making four bonds. Three and one, four. This is making three bonds. This is the fourth. So this is of three carbons. And this will be called what? C3H, 1, 2, 3, 4. And this will be called propine. Yes. And if you see the general formula, CnH, so C2H, 2 times 2 minus 2, that is C2H2. Clear? Then if you have C3H, 2 times 3 minus 2, that is C3H4. Clear? So this right here is alkyne functional group. Now, let's have the other functional groups. Is all of this? Now let's continue with halogenoalkanes. So this is basically the R group attached to a halogen. What was the R group? The alkyl. Yes, because alkyl had free bonds. If you remember, one vacant bond right here. The alkyl has one vacant bond. And since it has one vacant bond, to that anything can attach. And that anything, if it is an halogen, we make halogenoalkanes. So it's basically the R group attached to a halogen. Yeah. Let's see the types. So you have fluoroalkanes, where you have R group attached to a fluorine. Then you have chloroalkanes, where you have the R group attached to Cl. Then you have bromoalkanes, where the R group is attached to Br. And then you have iodoalkanes, where the R group is attached to iodine. Yes. So if you have a R group or an alkyl attached to a fluoro, we call those fluoroalkanes. Attached to a chloro, we call them chloroalkanes, bromoalkanes, and iodoalkanes. So let's see halogenoalkanes. So what were your R group? One hydrogen less than an alkane. So let's say this was the R group. This was the methyl group. Yes. And then to this you have, let's say, a chloro attached. So we will call this what? Chloromethane. Yes. Or if you have a fluorine attached, let's say, we will call this fluoromethane. Let's see if you have 1, 2, 3, 4, 5 hydrogens. One hydrogen less than an alkane. Yes, this is the ethyl group. And to this, if you have Br attached, we will call this what? Bromoalkane. If you have, let's suppose, iodine attached, we will call it what? Sorry, not alkane, ethane, because it's two carbons. So this will be called iodoethane. This would be called bromoethane. Do you see R groups attached to a halogen is what gives you halogenoalkane. And that's how you name it. The halogen first and then the name of the alkane. Clear? Because it becomes like an alkane, right? You'll be like, Miss, isn't this an alkyl? It is an alkyl, yes. But when the fourth bond is complete, it becomes like an alkane, saturated compound. So that's why we call them halogenoalkanes. Is this clear? Is this understood?